We are in geometry. I have my tablet back and it is nice and updated and brand spanking new. Today's date is Friday, September 11th, 2020, Memorial Day. Well, not the right word, but you guys know what I'm talking about. Objective. Who wants to read that? Ulysses, go for it.
Perform dilation on triangles and recognize properties of dilations.
There it is. Yeah, thank you. So I think like the first half of this, perform dilations on triangles, it's really review. It's just a lot of doing the same thing that we're doing before. What's going on? Come here. My Zoom is being weird. Where you're just dilating the same points over and over and then connecting them with a triangle if we were doing it on some paper, but it's kind of simpler than that on Khan Academy. So for this one, example one, we're going to draw the image of ABC, triangle ABC, under a dilation whose center is P, and we have a scale factor of 1/3. We're going to multiply all of these lengths by 1/3. So here's your general procedure that I created for you guys. You don't need it. It's really just boiling down to logic, but if you really need some help, here are the steps. So step number one, we're going to find the x distance between P and A. So in fact, yeah, let's do that. Okay, so the x distance between P and A. So P has an x coordinate of -7 if I draw down to the x coordinate or x axis, and A has an x coordinate of -4. So the distance between P and A in terms of our change in x, our delta x, if you will, 1, 2, 3. So I can come over here and say that is our change in x is equal to 3. Okay. From there, we're going to multiply it by the scale factor to find the x distance between P and our image A prime. So 3 times 1/3. So I'll write down 3 times 1/3. Another quiet raised hand to do a little bit of math for me. 3 times 1/3 is what? Wyatt.
1.
1. Perfect. So that's going to be our new change in x. Okay, so let's do a little bit more math and then we'll actually do these operations, but maybe we want to circle 1 because it's going to be important. That's our new change in x. Okay, then step 3 is we're going to do the same thing for the y's. Find the y distance between P and A. Okay, well, P has this y coordinate of 7, and A has this y coordinate of 8. So it's a big distance. So it's technically -8, sorry. So really I'm saying my delta y here has a change, and you can do one minus the other or the other one minus the other. It doesn't matter. Just know that your distance is always going to be a positive amount if you're just talking about distance. So I'm going to say 7 minus that -8. You can just subtract 1 from the other, and that's going to be 15. Sorry, our change in y here is 15. I guess you could count the squares too. I just worry that I might make a mistake. I feel like the hardest thing in math for me is counting correctly. It's so difficult. So let's go ahead and delete those. So we know our change in y is 15. And again, we're going to multiply this delta y, our change in y, by the scale factor. So I'm going to come down here and say, okay, I have 15, and I'm going to multiply that by 1/3. And another quiet raised hand, 15 times 1/3 is what? Charles.
5.
There is 5. And I'll circle it. So if I start from P now, and I guess like I could have like but I could have a ton of steps for what you're supposed to do. But from P, it's saying our new change in x is 1, our new change in y is 5, and you're going to get is equal to 5, and you're going to head towards our point A. So I'm going to go 1 to the right. It doesn't make sense to go 1 to the left because that's moving away from me. So I'm going to move 1 to the right, and I'm going to move 5 not up because that's moving away from me. I'm going to move towards it. I'm going to move 1, 2, 3, 4, 5 down, and that's my ending spot. So I'm going to get rid of those, and that is my A prime. I'll say this is our A prime. Is there someone that can give me a quiet raised hand? How could we verify? There was a method that I showed you guys yesterday to verify if that was indeed a dilation. Jade?
I think the one word you used was line. You can check
Line.
it with a line.
Yeah, and do you remember the specifics? Like, do I draw a line right there? Like, where do I draw a line?
You draw a line starting at P and through your starting point. So A instead of
Yeah,
A
exactly.
prime.
Yeah, the source.
Yeah.
The starting point, yeah. And it does go through A prime, therefore we verify. I mean, it might not be the right distance, but it looks about the right distance too. I mean, this distance looks a third of the entire distance. It looks good. I mean, I'm eyeballing it. Okay. And then we're going to repeat this process over and over for the next 2 points. So I think you guys can probably do this. Let's just do a vote with our cameras. 1 is let's do it together. 2 is let's do it by ourselves. Vote. 1, do it together. 2, do it by ourselves. 1, do it together. 2, do it by ourselves. Or I guess you could not vote too.
Yeah, not really. 1.
I'm just gonna, okay, you can go ahead and mute me if you don't want to hear me and just do it by yourself. I really prefer you guys to do it by yourselves. It's better practice than me giving you hints and solutions. Maybe I'll stop sharing my screen and I'll wave my hands and say, hey, like, come back or something like that. So go ahead and mute me. Here we go. Let's do B because I'm just alphabetical order. Sure, why not? Okay, so B, let's do it all in orange. I need to find the total change in X, the total change in Y. So how do I do that? Well, B's X coordinate is 5. Again, P always has the same X coordinate, it's -7. How do I find the total change, or can someone calculate that for me with a quiet raised hand? Total change in X. Change in X. What's the change in X to get from -7 to 5? What is my distance here? Ugo, yeah.
12.
12, yeah. And if you need to do the math, 5 minus -7 is really 5 plus 7, which is 12. Perfect. Okay, now I need to find my change in Y. So look at the Y coordinates. Y coordinate was 7, and Y coordinate is -8. What is the change from 7 to -8? What's the total distance there? What is 7 minus -8? Ulysses? Oh, sorry, Kira.
15.
Yes, 15. Nice. So come down here and say 15. And again, I'm going to multiply each of those by the scale factor. So this is going to be scale, I can't spell, scale factor. Oh, God. Scale factor, so times a third, and I'll get my new distance to get to the image, from the source to the image. So multiply, I need someone to do both of these multiplication problems. It was 12 times a third and 15 times a third. That's going to be given to Kira.
So 12 times a third, I think, is 4, and 15 times a third is 5.
There it is, yeah, 4 and 5. Then we're going to count that many distance, or that much distance to the right and down, because that's heading towards B. So I'm going to count 1, 2, 3, 4. 1, 2, 3, 4, 5. And I guess you could just look at the original X and Y coordinates and just do it mathematically too. But we do end up here at -3, 2. -3, 2. I should use orange for this, -3, 2. And that is theoretically should be B prime, but I'm going to check it by drawing a line. Let's go ahead and draw a line from P. No, I don't want to drag you. Okay, let me just drag it off to the side and get to B and then redrag this side. And hey, yes, I mean, my point was a little bit incorrect, but it definitely goes through those crosshairs, through that lattice point there at -3, 2. Looks like I got it correct. All right, and then we're going to do it a third time. So I'm going to use a new color here. No, go back. No, why? Computer. Okay, now I'm going to change to, let's go to green, yeah. So C, I'm again trying to find the new X and Y coordinates. So where's some room off to the side over here? So my change in X to get to from P, the X coordinate of P to the X coordinate of C, from -7 to 8. Again, I can go 8 minus -7. And oh, I gave it away, darn it. Okay, well, it's 15. And then my total change in Y here. I had a Y coordinate of 7, and then I go down here to a Y coordinate of 4. You can literally count the spots, or you can just quickly hold up on your hand. How many is 7 minus 4? You guys are all holding up the number 3. Yes, I see why it's holding it up. 3. So, oops. come down here and say that's equal to 7 minus 4, which is equal to 3. And again, we're going to multiply those both by the scale factor. So here I go again, times a third, times a third. And I'm feeling lazy. I'm just going to do this for you guys. 5 and 1. So I'm going to go 5 right, down 1. Let's count them. 5 right. 1, 2, 3, 4, 5. Down 1. Chunk. So right here at the coordinates -2, 6. And to verify that that's actually correct, I mean, I'm eyeballing it. It looks good, but let's really make sure it's correct. Start from C instead of P this time. And hey, look, it looks good. I should also label the point. This is C prime. So you can probably delete the lines or erase the lines if you need them, but we need to draw the original triangle again. I mean, on Khan Academy, it's already drawn for you. It's electronic. But let's see, what do we have here? I don't know how I'm going to be able to draw this line without moving these lines because it always wants to move lines. Is there a button I can hold down on my keyboard? Maybe Option? Okay, maybe I'll just draw the line connected afterwards. That works too. So let's go from that point to that point and give me another line, this point to this point. All right, this black triangle, A prime, B prime, C prime, is the result of triangle ABC under a dilation by a scale factor of a third with a center of dilation of P. It's a long-winded way of saying, yeah, we shrunk it down heading towards P. All right.
Mr. Sindel, how do you know if you'd go like left and down with the 6?
Yeah, so to get from P to the original source A, I went left and then down. So that means I'm also going to be going left and down to get to A
Oh,
prime.
okay. Oh, okay.
It's the same moves. Good question. And I guess if I was being more careful with my negatives and I said I went -4 and -4, then I get -6 and -6. You could, if you want to be careful with your negatives and positives, that's another great way of knowing which direction you're going. -4 in the X direction means left, right? Or left, correct.
So if like something doesn't move, like doesn't, I guess the change in X, like there isn't a change in X, what would you do for that? Would it just be 3/2?
Well, that means the change in X is 0, and 0 times the scale factor of 3/2 is
Okay.
still 0. Yep. All right, so moving on to properties of dilations. When comparing the source to the image, the angles are, and this is kind of one of the interesting things about rigid transformations and dilations as well, is that no matter what, all four of your different transformations will always have congruent angles. So I'm going to say congruent here. And because we're talking about dilations and we're not talking about rotations, reflections, I always forget I know the three. There's translations, rotations, reflections. I forget which one I said first though. Short-term memory loss. But those all preserve distance, but dilations don't, right? Distance either gets squished or it gets bigger, it contracts or it expands. So line segments do still have a property though. And the property is that they're parallel to whatever you started with, and they're proportional. Which seem like that last part, proportional, seems silly for me to say that again, because proportional is just a word saying you've multiplied by the same number. Well, of course you've multiplied by the same number. You've multiplied by the scale factor, which hopefully should not have changed. So I'm just going to say here, multiplied by scale factor. And I know there's a lot to copy down here, but I've got 3.5 minutes now, so kind of have to go through this a little bit faster than I would like. All right, so if the points, the points might have the same coordinates. If I'm doing a dilation, and this is, I know that everyone's frantically copying me down, but this is the critical step of today where you really need to do some deep thinking. So maybe go back through this and really ask yourselves, when do the points have the same image and or the source and the image? My start and my end, how is it possible to have the same exact coordinates? Yeah, Kira?
Well, I think that could only happen if P was on that point. Like if there's 0 change in Y and 0 change in X to get from P to that point.
Yeah, so if the point is on that point of dilation. And as Kira kind of pointed out, like if I was on P right up here and I had another point on P and I dilated it, like you're not going to move. All right. So another interesting property that the line segments might be on the same line, and that actually happened to us, right? Look up here. No, we didn't. Do we have one down here? Yes, we do. This line segment right here will be on the same line down here. Like it'll kind of extend the line almost. That happens when? And I just have to write these down because we have 2 minutes left. So if the line segment points towards that P. And I'm calling P the point of dilation, so I could have said P up here. Point of dilation, it's just quicker to write P. I'm using Kira's terminology. And then finally, the areas and perimeters might be the same if there's only one case where this will be the same, and it's if you didn't really dilate it. If dilation scale factor is 1, which is the equivalent of saying you didn't really dilate it. So maybe this is kind of, maybe I should eliminate this for next year. This is kind of dumb to say, like, hey, if your dilation factor is 1, you didn't really do anything. You have the same exact image and source. But yeah, you could have a scale factor of 1. If I had more time, it would be fun to play around with that and ask you guys more questions. But let's do example 3 because we have 45 seconds left. Quadrilateral A prime, B prime, C prime is the result of dilating ABC about to point P by a scale factor of 2. Which of the following properties are true? Okay, and then you have to go through these one at a time. The measures of angle D and measure D prime are equal. And this is a property of dilation. This has to be true. And there's going to be multiple of these that we're going to select, because angles under any transformation that we've learned so far are always going to be equal. So I don't even need to have any graph over here. All angles are always going to be equal. Okay, what about B? The coordinates of C and C prime are the same. Okay, well, C and C prime are only going to be the same if they're on the point of dilation, and none of these points are on the point of dilation. So no, the answer is no for B. What about C? Line, okay, I'm 6 seconds over. If you guys want to go take your break, you can. I have like about 2 minutes left of this video. So if I don't see you again, have a nice weekend, but I'm gonna continue the video. C is saying line segment AB and line segment A prime B prime are on the same line. And this is probably the hardest question to answer, but it is correct. And I'll show you why. So here's AB. And if I do have a scale factor of 2, that means A is going to be dilated 2-way and A prime is going to be on B, and then B prime is going to be down here somewhere. But the cool thing is, because AB, this line segment, points exactly towards our point of dilation, like if I were to extend this line segment AB to P, it would intersect P. That means that if I draw a line down here, these points are going to be on the same line. Everything here kind of lines up, which is pretty cool. So C is correct. That only happens when line segment AB points towards point P. What about D? Line segment CD and line segment C prime D prime are parallel. And again, I have told you this up here. Points might, or where is it? The line segments are both parallel and proportional. And it's saying, hey, are these line segments parallel? Yes, they're always parallel. Under every dilation, they're always going to be parallel. Again, it's one of those, I don't even need to look at this graph to know, yes, they're going to be parallel. It's just a property of dilations. And if you want to like see a visual, so CD is right here. If I were to copy down CD, maybe draw a line right here, CD. And literally what I do is I move it away and kind of make it bigger with the same angle. It's going to be like down here somewhere, but check it out. Yeah, they're both going to be parallel. And you can look up here too. All these were parallel. Look at A prime, C prime, and compare it to AC. Like look at this line segment and this line segment. They're parallel. It's just a property of dilations. And then finally, E. The area of ABCD and A prime, B prime, C prime, D prime are the same, and no, because that will only happen in one case, and this one, the scale factor is 1. All right, I did go over by exactly 2 minutes. That is the end of this, the notes, and the end of the notes for all of Unit 1 geometry. Get ready for a quiz on Monday. I'll see you guys on Monday, unless I see you guys in Algebra 2.
Okay, thank you.